Hi, my name's Lucy. I'm one of the Elevate UK presenters, and today I'm going to be taking you through a GCSE Chemistry Paper 1. Now this one's from June 2014. As we go through, I'm going to try and give you the best explanation I can as to why the right answers are the right answers, but I'm also going to go through where I went wrong answering these questions and how we can make sure we don't make the same mistakes by looking at, firstly, the mark scheme, going over exactly what the examiner wants, and then we're going to take a look as well at the examiner's report to see where other people made the biggest mistakes and how we make sure we're not going to do that ourselves. Okay, so we're going to start with this first question. This first one's looking at an electron diagram, it seems. We're not quite sure which one yet, but I have highlighted. If we look at the question, it's asking us to complete the figure to show the electronic structure of a carbon atom. So we know that carbon has 6 electrons. We know that because we've gone to our chemistry data sheet, we'd have had a look at the periodic table, and it says that carbon has 6 electrons. Now, when it comes to filling in electrons in these shells, it's really important that we start from the inside and then work our way out, because electrons will always fill the lowest energy level possible. That is the one closest to the nucleus. We know this because it says so in our syllabus. Right here under C.1.1.1, this one here, H, electrons occupy particular energy levels, and in particular, the electrons in an atom occupy the lowest available energy levels right there. So that means when we go back to our paper that we're going to start filling in our electrons here, closest to the nucleus, and then fill them outwards. Now we know that the lowest energy level, this one on the inside, it can hold 2 electrons. The outermost energy level in this diagram can hold 8. So we've got 2 in the middle, 8 on the outside, but we don't have enough to fill the outer shell completely. So if we start on the inside, we'll have 2 there, then we're going to have 4 on the outside. When we're drawing these diagrams, we want to make sure that the electrons are on kind of like clock faces around the nucleus. So we're going to have 1 at 12 o'clock, 1 at 3 o'clock, 1 at 6 o'clock, and 1 at 9 o'clock. Of course, only 2 can fill the inside layer, so we're going to have 1 here and 1 here. If I get my pen, then if I was drawing this in the exam, I'd start by putting 1 electron there, 1 electron there. There, we filled the inside layer, the lowest energy shell. We've got to then move to the outside one. So remember, electrons want to be as far away from each other as possible. We go around the clock face with our 4 electrons and count up 1, 2, 3, 4, 5, 6. There, perfect, 6 electrons. That is a carbon atom. If there are more electrons, after filling those outer 4, there's still 4 electron spaces here, 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 and here. So you'd start putting crosses there as well until you have the full 8. But of course we don't, we've only got 6, and there is our full answer. If you did that in the exam, you'd get the full mark. So we're going to look at the next question. 2a, complete the word equation for the oxidation of hydrogen. We've got hydrogen plus oxygen goes to something else. We've got H, we've got O. One of the main things it's going to be is you're going to create water. I'm pretty sure a wrong answer would be hydrogen monoxide, or peroxide, or any of those things. Should we have a look? If we go over to the mark scheme, it says water vapour or steam is the correct answer. Allow hydrogen oxide, or H2O. You could even write the chemical equation. Do not accept hydroxide. So a few of the things we're not allowed to write down. What I am going to write down instead, though, is the right answer, water. We know the 2 together create water. Fab, 1 mark. Next. Coal is a fossil fuel. Coal contains the elements hydrogen, sulfur, oxygen, and carbon. Name 2 products of burning coal that have an impact on the environment. What impact does each of the products you named have on the environment? So if we break this question down, there's 2 key things we want to look at. Okay, what is the question asking, and how many marks can we get for it? Answering that second one, 4 marks. Okay, that's the first thing we want to look at. I think I'm writing in not a colour, there we go, 4 marks. The next thing I want to look at, how are we going to answer this question and get those marks? Name 2 products of burning coal, and what impact does each of these products you named have on the environment? So if there's 4 marks, then I think there's going to be 2 marks for the 2 products, 2 marks for each impact. One thing I just want to make really clear, which is something that I always used to get wrong when I did these exams, is that you can actually lose marks you've gained for writing a list that you haven't been asked to write. As an example, it says here name 2 products. A lot of students will write 3 or 4 because they know them, or they'll write 3 or 4 in the hope that at least 2 of them will be right, which then will give them the 4 marks. Problem is, if you write 2 perfectly good answers to get you the 4 marks, but then write a third one that's wrong, you can actually lose the marks you gained for a correct answer. Now, that's something that is written on the mark scheme for examiners. Let me show you here. Information to examiners. This one here, the marking of lists, is the most important point. There's this rule that the examiners have, which is right plus wrong equals wrong. This bit right there. What that means is that you write the right answer, then you write a wrong one, you negate the right answer, so you then lose marks. It is really, really tempting to write as many things as you can, but the general rule of thumb I'd stick to is if it says 2 products, name 2 products. Be confident with it. Write a full answer, explain yourself as well as you can, and there's no reason you can't get those 4 marks. So how would I answer this question? I'm going to focus on 2 of the key elements in coal that can create a real issue when it comes to the environment. One of the first ones is that stands out to me is sulfur. I know sulfur can create sulfur dioxide. Now, sulfur dioxide is a key cause of acid rain. And of course, carbon, we know, can create loads of issues, including carbon dioxide, which causes global warming, as well as carbon monoxide, which is, of course, poisonous or toxic. We want to focus on those 2, as it says, name 2 products and the impact each of the products have. So I'm going to break my answer down into 2 sections. I'm going to start off by talking about carbon dioxide. I'm going to say burning coal creates carbon dioxide, which causes global warming. So that's going to be my first answer. I'm also going to go on, full stop, another product of burning coal is sulfur dioxide, which causes acid rain. So I've got my 3 answers. Here we go. Apologies for not fitting in the lines. Burning coal creates carbon dioxide, which causes global warming. Another product of burning coal is sulfur dioxide, which causes acid rain. I've got my 2 things that are created, carbon dioxide, sulfur dioxide, and the 2 impacts they have on the environment, acid rain and global warming. If we go over to the mark scheme, it tells us exactly what the right answers would be. So we've got any 2 pairs from carbon dioxide. There we go, that's our first mark. Causes global warming, 2 marks, straight off. Also, you could have greenhouse effect, climate change. You can actually see from this column, there's loads of answers they'd allow. So you have quite a lot of leeway in exactly what you say. But there's not any leeway for the products, so make sure we get those right. Another example could be carbon particles or soot causes global dimming. One of the things I saw in the examiner's report is that actually a lot of students got those 2 mixed up. A lot of students said that carbon dioxide causes global dimming, or vice versa, which of course does not get you the mark. So make sure we correct that, make sure we've got those 2 the right way around. Here we go, carbon monoxide, that's the other one I talked about, which is toxic or poisonous, and sulfur dioxide, that's one of our answers, 1 mark for that, 2 words, 1 mark. Causes acid rain, another mark right there. Again, other examples of what you could say, but straight into the point, causes acid. All right, so on to question number 2. This one's looking at ethanol and vegetable oils, which you can use as fuels. 2 different ways to produce ethanol, using ethene, making it from crude oil, or using sugar from plants. The question we've got to answer first. Ethanol is produced from ethene by hydration in the presence of a catalyst. What is hydration? Now, actually, if we go to our syllabus, we can see right here, there's a whole section on ethanol. It says, A, ethanol can be produced by hydration of ethene with steam in the presence of a catalyst. So it's actually straight in our syllabus, the answer that we have to write down. You could write adding steam, is what hydration is. Or actually, if you just think about it in general terms, if I was dehydrated and I needed to fix that, what would I give myself? In order to hydrate myself, I'd need water. So the perfect answer you can write down is hydration is the reaction with water. You could also write steam. Actually, if we go over to the mark scheme, reaction with water or steam, both of them are allowed. Notice actually, sorry if I flick back, it says ignore mix. So you can't just write mixing with water or whatever. It's a reaction with water. That's what specifically hydration is. So let's move on to the next question. You can already see I've kind of put the answers in, but let's work through from the top. Fermentation is used to produce ethanol from sugar by dissolving the sugar in water, adding yeast to the sugar solution, leaving the mixture for 3 days. So we know on our syllabus that we understand what fermentation is. It's actually part of our syllabus. If we pop here, it says here ethanol can also be produced by fermentation with yeast using renewable resources. This can be represented by sugar goes to carbon dioxide plus ethanol. So actually the question isn't asking us anything about that part of the knowledge. In fact, it's given us that, as you can see here. What it's asking us is something different. Figure 2 shows the substances after 3 days. The solution of water and ethanol is lying on the top, and then you've got solid waste yeast at the bottom in like a layer. It's asking us to suggest how the solid waste yeast is removed and how ethanol is obtained from the solution. So 2 things. If we again focus on how many marks there are 2 marks that can be given. So 1 mark for answers to both of these things. Answering the first part, how the solid waste yeast is removed, my answer would be, well, if you try and think about how you'd remove sand from water, you've got to filter it. And it's exactly the same thing. You've got to take a solid away from the liquid. So my answer would be the waste yeast could be removed by filtering the substance. That's going to be my first answer. The second part of the question is asking how ethanol is going to come from the solution. How can we just separate the ethanol from the water? Now, if you think about getting rid of water in any kind of substance, one of the things you could do is evaporate it. You could remove the water, it would evaporate, you'd be left with ethanol at the end. However, we do also know that to get ethanol from a solution with water, you can also get it by fractional distillation. You don't have to write fractional in, but my second answer, as you can see here, is the ethanol could be extracted from the substance by distillation. So I said 2 answers there. It could be evaporation, could be distillation. Shall we see if both of those answers would be accepted? If we go here, 2AII, first part, how would you get rid of the yeast? At the bottom, filter or decant to remove the yeast, perfect answer. And down here we can see that fractional distillation or just distilling is a perfect answer, although of course it also accepts evaporation, then condensation. Notice though, if it does say evaporation, you then have to condense it again at a different temperature to get the ethanol out of it. Do notice as well, it says ignore sieve. That first part, you know, filter, sieve, doesn't seem like there's much in it, but it's the filtration that's actually going to separate that yeast from the solution, not just sieving it.